Hello everyone, welcome to week 4 tutorial session today. Today we will be going over data manipulation with pandas. So first over, we are gonna learn what is pandas and why they are useful. And I will briefly explain about the data set we will be working on today. And there are lots of things you can do within pandas. You can get basic information about the data set, and today you will learn how to clean the data set. So part of the cleaning process requires you to remove some non-values and removing specific columns. And sometimes you want to select subsets of data based on your interest and based on some criteria. And you will also learn how to filter data set based on specific criteria. And there are some useful aggregate functions such as sum, min and max, min and count. And once we learned how to work on data manipulation using pandas, we are gonna be working on another data set. So I will briefly explain about the data set and we are gonna apply what we have learned in this lecture. And today's lecture, we are gonna have some time to work on now try these sections. So you can always ask questions in the chat, and Atul and Shayan can answer your questions in the chat while I'm going through the lecture materials. But in between the lecture materials and the practical exercise, I will pause for some time, and feel free to ask us any questions you have before we move on to practical exercise. So first over, what is pandas? So this week we are going to cover the basic manipulation using pandas. And pandas is an open source data analysis and manipulation tool, and it is widely used both in academia and industry. And as to why this is widely used, pandas is designed specifically for data analysis and data manipulation. And you're gonna see that pandas is slightly easier than Python since this is specifically designed for data analysis, and it also offers data structures and operations for manipulating numerical tables and time series. Pandas provide three main data structures: series, data frame, and panel. A series is one-dimensional labeled array, and one-dimensional array represents a single column in Excel. It can hold any type of data, such as integer, string, Python object, and any kinds of data set, any kinds of data type. And each value of a series has a corresponding labels, and the labels are called indices. And we are gonna learn the basics of series in week 7. And today our main focus will be on the data frame. Data frame is two-dimensional labeled data structure with rows and columns, and two-dimensional array represents a tabular data. So this is like a table in an Excel file. And the panel is three-dimensional. Yeah, as I said earlier, we will focus on data frame today, and we will learn the basics of series in week 7. And we will not cover panel in this semester because it's not used as often as two other data structures. And since we've covered the fundamentals of Python, hopefully it'll be easy to pick up pandas today. So this is what we will be learning today. So we are gonna get a quick overview of the dataset, and this is the first thing you needed to do whenever you work with the dataset. Because if you don't know what the data looks like, or if you don't know what you want to get from the dataset, then it's meaningless to work with data. So before you define your problem, or before you understand your problem, you needed to know what the data set has and how the data looks like. And this is part of the cleaning process. You're gonna learn how to remove column and rows with non-values. And this is very useful when you are working with large data sets. So for example, if the data set has 100 columns, but if you are interested in only 5 columns, then you want to select specific columns based on your interest and based on your project. And at the end of the tutorial, we should be able to analyze the survival rates in the Titanic data set. And similar to last week, you are gonna need to submit. Now try these sections, and this code is gonna make it easier for you to submit the file. So I'm running the file, and it's gonna ask me to type in my student ID. So I will type in the 9-digit student ID, and now the directory has been created. And you can check that your directory has been created on the file section. And I will give you a brief explanation about the dataset. So the dataset we will be using is the Titanic Data Set. And as many of you already know, Titanic was a British passenger liner operated by the White Star Line that sank in the North Atlantic Ocean in 1912. After striking an iceberg during her maiden voyage from Southampton to New York City. Of the estimated 2,224 passengers and crew aboard, more than 1,500 people died. And this dataset does not have all of the passengers' information, but it has the information for approximately 1/3 of the passengers. And the informations include name, age, gender, ticket price, and most importantly, whether or not they survived. And each person has its unique passenger ID, so each row represents a unique entity or unique passenger. And you needed to import Pandas library whenever you see a dataset, whenever you want to work with a dataset. So it's a convention to say import Pandas as PD, and this basically means that we are gonna import Pandas and we are gonna rename Pandas as PD. So whenever we want to use any functions in Pandas, we can use PD. And to read the CSV file with our dataset, we are gonna use read CSV function. So this is where our dataset is located. So this dataset is in a format of CSV. So this is the function we are gonna use, read CSV. And as I said earlier, since we have defined pandas as PD, we are gonna call PD and enter that and read CSV function, and we put in the data location. So this is how you can load data frames, and I save the output as a DF. DF stands for data frame, and since we are working with only one data set, one data frame, we are just gonna call it DF. But if we are working with multiple data frames, then it's better to give meaningful name, not just DF1, DF2, but Titanic data or passenger information or passenger survival rate, things like that. So this is what DF looks like. It's got index column, passenger ID, survived, pick class, name, sex, age, SIP, SP, perch, ticket, fare, cabin, and embarked. So the very first column is an index column, and it starts from 0 by default. So basically it's index 0, index 1, index 2, and index 890. But as I mentioned earlier, passenger ID is a unique index. So we are gonna set passenger ID as an index. So this is the function you can use. We are gonna redefine the index in the data frame DF, and we are gonna set index, and the index is going to be the keys. So key is set to passenger ID. So after you run this block of code, passenger ID is going to be the index of the data frame. But let's call df one more time to make sure that df has been updated to reflect the change. And once you call the df function, it doesn't seem to change. It doesn't seem to be changed. It looks like the previous data frame before we set passenger ID index. And do you know why the change has not been made in the data frame? This is because this function call sets passenger ID as an index when we call the function, but it doesn't save the change. And since we didn't save the function call or the changes, df has not been updated. So there are two ways to update the data frame. you can use the first method, and the first method basically creates another variable df and reassign the output of the data frame as df. And the second function call makes changes in place, and you just needed to type in place. It's set to true. So for now, I'm going to use the second method, but there's no difference between the two code. And now passenger ID is set to index. And let's get basic information about the data frame. And as I mentioned earlier, you need to get the basic information about the dataset before you working with dataset. Yeah, because it's better to know what you can get from the dataset and what information is available within the dataset. And head function is useful to see the dataset at a quick glance. And by default, df head is going to return the first 5 rows. But if you want to get an extended overview, then you can specify the number of rows to display. So if you put in 10, it's going to display 10 rows. And to get the summarized information within the dataset, you can use info function. And this function returns the column names, non-null counts, as well as the data types. So it's got all of the column names and it says how many values are non-null. So basically, this means that 891 values are non-null, and this means that 713 values are non-null. That means more than 200 values are non-values. And it's got the data types. So as you can tell, age and cabin have lots of missing values since it has such a row non-null counts, and there are 3 data types in the data type columns: int 64, object, and float 64. We have covered int and float in the previous section. Int means integer values and float means floating point numbers. But what is object? Object is a string or mixed numeric and non-numeric values. And that's why name, sex, and in-birth is an object because they are string. And ticket and cabin are object because they are composed of numbers and string plus numbers. Yeah, string plus numbers. Describe is used to view summary statistics of numeric columns. One thing to note is that describe function displays summary statistics of numeric columns only. And that's why it's returning 1, 2, 3, 4, 5, 6 columns because only 6 of them are numeric columns. It returns count, mean, standard deviation, mean, 25 percentile, 50 percentile, 75 percentile, and max. Count, mean, minimum, and maximum are pretty straightforward, but just to refresh our memory from statistic class, standard deviation (STD) stands for standard deviation, and the standard deviation measures the dispersion of a dataset relative to its mean. If the data points are further from the mean, there's a higher deviation within the dataset. And if the data points are closer and closer near the mean, that means it has a lower deviation within the dataset. And 25 percentile is the value below which 25% of the observations may be found. So for example, 25 percentile of age is 20.125 and 75 percentile of age is 38. This means that 25% of the passenger's age is less than 20.125 and 75% of the passengers' age is less than 38. So this gives you a brief overview of the numeric columns. And to see the size of the dataset, you can simply type in df.shape and it's going to return the number of rows and number of columns. And now we are moving on to cleaning process. So when you work with large data sets, there will be lots of non-values and those values are meaningless. So it's good to remove those values and to work with clean data sets. So let's remove the rows that do not provide a meaningful information. So we know that passenger ID is a unique key and we can check whether all elements have passenger ID. And if any of the rows are missing passenger ID, then we can drop that entity. So this is what we are gonna do, drop the rows where, so the first function is going to drop the rows where at least one of the elements is missing. So this function is very strict. And the second function is going to drop the rows where all of the elements are missing. So we don't want to keep any rows that do not have any information. And the last column is useful as well because we can define which columns to look for missing values. So this is going to drop the rows with at least one missing value. So now the result is 183 rows. And if we want to drop the rows with all elements missing, then we can specify how. And we can tell that none of the rows are missing all elements, which is good. And now we can define which column to look for missing values. So we can specifically select survived column and it's going to drop the non-values if it's going to drop the rows if the row has missing survived value. And now you can tell that none of the rows are missing survived column. Yep, and as always, if we want to update the dataset after dropping rows, then we can use in place equals true. Okay, so similar to what we have done earlier, now you can try dropping the rows that are missing P class, and you needed to update the data frame. So you can either use in place set to true, or you can recreate a variable df and you can reassign the updated data frame. But before you do that, because you have not run any of the codes above, you're gonna need to go back to the top and you needed to run the code from here up to now try this number 1. So you're gonna need to run this, root file, and everything up to now try this. And once you do that, you can type in your answer here and it's going to look very similar to this code right here. And once you confirm your answer, then you can uncomment this line of code and you can save your answer to number 1. So I'm going to give you 3 minutes to run everything and to work on this problem. Let us know if you have any questions. And before we dive into the data analysis, let's see if there are any columns we want to remove. And as I mentioned earlier, this cabin column has lots of missing values. About 687 rows are missing in the cabin column, so we are gonna remove this column. So you can use del or delete function, del df bracket and cabin, and it's going to delete the df cabin column. So now you can tell that the cabin column is not in the dataset anymore. And lots of times we are gonna be interested in working with few columns to do the data analysis, and we can select a specific subset of columns using two methods. You can select columns by index location or by column names. So because we are using index location, the syntax is index location, and that's why it's I and LOC. And you're gonna define the row index and the column index. And as we have run last week, this colon selects everything in a list or a string in Python. So if you put just semicolon in row's location or column's location, it's gonna select every row or every column depending on where you put it. And let's select passenger ID, survived, and pick class. And as you know, passenger ID is located in the first place, second place, survived is in the second place, and pick class is in the third place. So I'm going to select 0, 1, and 2 to select passenger ID, survived, and pick class. And this is what it returns. It returns 4 columns. And do you know why 4 columns showed up? And let's look into why. Because passenger ID is a default index, it's gonna show up automatically. So you don't need to select index. Instead, you needed to only select survived and pick class. And survived is going to be located at index 0, and pick class is located at index 1. So now you can try selecting passenger ID, survived, and pick class with all rows. As I said earlier, survived is at index 0 and pick class is at index 1 because passenger ID is not part of the columns. So you can try this section, and I'm going to give you 1 minute to work on this problem. Okay, in the next, now try this section. Now you're going to select the same thing, but this time you are gonna need to use semicolon. And just to give you brief summary of the semicolon, if you select 0 to 3, it's gonna select 0 to 1, 0, 1, and 2 because this last number is exclusive. And if you do 1 through 5, it's going to select 1, 2, 3, and 4. So this number is inclusive while this number is exclusive. So hope this makes sense, and let us know if you have any questions. And you can select specific columns using column names. And we are interested in passenger ID, survived, sex, and age. So this is what I have put in: passenger ID, survived, sex, and age. But we get an error message saying that passenger ID not an index. Yeah, as I said earlier, passenger ID is no longer a column because it's an index. So we can select it by a column name. So now you can try selecting survived, sex, and age, but remember the error message we got. We can select passenger ID. So I'm going to give you 1 minute to work on this problem. And moving on to filtering data set, we are gonna learn how to filter data set based on criteria. And oftentimes we want to select specific rows that meet certain criteria. So for example, if we are interested in the passengers whose age is greater than 30, then we can use this syntax. So LOC represent locate. So we are gonna locate the rows that meet this criteria. So this is when you have to do data frame, enter that, locate. Inside the bracket, you put in your condition. So this code, so df over 30 years now represents only the passengers whose age is greater than 30. And if we want to do multiple criteria or multiple conditions, then we can use this ampersand, and this ampersand is equivalent to and this vertical line is equivalent to or in the data frame. But one thing to note is that when you put in multiple conditions, you specifically needed to put in the parentheses, otherwise it's gonna throw an error. So as I write it down here, when filtering with multiple conditions, make sure to use parentheses on each condition. Otherwise, you will get an error saying that the truth value of a series is ambiguous. And this is the data set whose age is greater than 30. And this is the data set that represent the ones whose age was over 30 and who also survived. So among the 305 passengers, only 125 passengers survived in this group. Now you're gonna try this section. You're gonna select the data set that meet the following condition where P class is not equal to 1. So I'm going to give you 1 minute to work on this problem and let Atul or Shayan know if you have any questions. And moving on to number 6, this is pretty similar to what we have done here. You're gonna put in multiple conditions and you're gonna use or statement this time. So make sure to use vertical line in the code. So you're gonna select the passengers whose age is less than 10 or whose age was greater than 50. Yeah, so I'm going to give you 2 minutes to work on this problem. And now moving on to the aggregate functions. Aggregation is the process of combining things, and it's very useful to understand overall properties of the data set and analyze it. And some examples of aggregation are sum, counts, mean, max, mean, and standard deviation. So this is very simple. So you're gonna select the column name and you're gonna get the sum of the column. So the total fare was $28,000. And if you want to round total fares and save it as a variable, then you can save the result as total fares and you can do the print statement. And this is basically the rounding function. And you can also count the number of passengers that survived by summing up the survived column. As you know already, the survived column is either 0 or 1. So if you sum up the survived column, it's gonna sum up the number of passengers who survived. So the survived number of passengers is 342. And we can calculate the max fare and the minimum fare using this syntax. And this is pretty simple. And as you know already, survived is either 0 or 1. So if we get the mean of the survived, it's going to return the overall survival rate of all passengers. And if we want to calculate the mean age of all the passengers, then we can do age and the mean. Now we will tackle a more complex problem. So we are going to calculate the survival rate by age group. So because we have identified that the average age was 29, the criteria is going to be 30. We are going to do filtering. We are going to create a data frame that's over 30 years and another data frame that's under 30 years. And we are going to calculate the mean of the survival rate by using this aggregate function for each group. And we are just going to print out rounded number for those passengers. And this is basically rounding this number up to 3 decimal points. And you can look at this specific definition if you are interested in. And as you can tell, there's not much difference between the two groups. The group whose age was under 30 has a survival rate of 40%, and the other group has a survival rate of 4%, so there's not much difference. So we will see if we group by sex, if there's any difference between the survival rates of female and the male. So we are gonna use the group by function. So it groups by sex and it's gonna calculate the mean. So it returns that the survival rate for male passenger is 74%, while the male passenger survival rate is only 90%. And if you want to search the aggregate function by a column, then you can apply search values and you're going to specify which column you are interested in to sort by. And since this line of code returns everything, every numerical columns, but if we want to know only the survival rate, then we can specifically select survived. So now it returns survival rate only. And as you can tell, there was a significant difference in the survival rate by sex. And you can also group by multiple columns. So if you want to group by sex and the pick class, you can do so by putting multiple column names within the bracket. And you're gonna apply the aggregate functions. So this is the result of group by sex and pick class. So the first line of output is female pick class 1, and the second line is female pick class 2, female pick class 3, male 1, male 2, and male 3. And as you can tell, in both groups, the survival rate was a lot higher in P class 1 than other P classes. So P class 1 is highest in the female group, and P class 2 is second highest, and P class 3 was the lowest in the female group. And this pattern is the same within the male group. So now we are curious if there is any correlation between the P class and the price. I'm thinking that P class 1 would have been more expensive because it has higher survival rate, but this is just my assumption and my guess. Let's check it out by applying the code and by calculating the mean fares for each class. So we are going to calculate the mean fares for each class, and the code is gonna look similar to this one. So I'm going to give you 2 minutes to work on this problem. So I believe that there's a correlation between peak class fare and the survival rate. And you can think about the relationship between the 3 vectors after class. And using data frame and aggregate functions in Pandas, we can answer any questions that might come up. And in the practical exercise, we are going to apply what we have learned, and we are going to further analyze a new data set. So in the practical exercise, we are going to be using US Census demographic data. And here's a brief explanation about the data set, and you can do lots of things within the data set. You can calculate unemployment rate by state, and professional working fields by state and county, and means of transportation to work by county in California. There are lots of things you can do, but since this data set is large and we don't want to work with like 50 states data set, we are going to select top 5 largest states by population. And once we've selected top 5 states, we will examine the residents' means of transportation to work at a state and the county level. And this is our focus in the tutorial, but feel free to play around with the data set and let us know if you have any questions. So we are going to load our data set first. So we apply the with CSV function as we have learned earlier. So now the dataset has been loaded as DF. And now you're gonna try setting county ID as an index. And I have done the same thing in the Titanic Data Set when we set passenger ID as an index. So you can refer back to the first part of the tutorial and make sure to run this part of the code to update the data frame variable. So I'm going to give you 2 minutes to work on this problem. As always, we are gonna get the basic information by calling head function, info function, and describe function. Yeah, there are 34 numerical columns out of 36 columns in this data set. And as I said earlier, there are lots of things you can do with this data set. So we are going to pick top 5 states with most population and most employees, and we are going to work from there. So as we have learned today, you can select specific columns by index location or by column names. And since this dataset has so many column names, let's take a look at all of the columns first. So you can use df.columns to display all of the column names, or you can use df.info as well. So either one's fine to take a look at all of the columns. And since there are 36 columns, it's gonna be kind of lots of work to count the index location. You are gonna need to count 0, 1, 2, 3, 4 like that. So for this specific data set, column name, selecting by column names would be more useful. So you're gonna select the county of the state, county, total population, income, employed, drive, carpool, transit, walk, other transportation, and work get on. So this is how you select the specific column names. And I renamed the data frame as df_employed, EMP. So this is the smaller data set we are going to work with. And now let's get some aggregation functions. So we want to get the total population by state, and we are going to select the top 5 states with largest population. And in order to calculate this, we needed to group by state, and we will need to get the sum of the total population. So as you know, state column is available here and the total population column is available here. So we are gonna group by state and we are gonna sum up all of the total population by county. So this is the instruction: calculate total population by state from df_emp and name the new data frame as state_population. So I'm going to give you 2 minutes to work on this problem. And once you do that, I'm gonna teach you how you can search by values. So when you run number 9 code, it's going to be it's going to be like 50 states with numbers not in order. So we are gonna order the population in a descending order. So this is how you can sort values by descending order. You're gonna say sort values and ascending is set to first. So this data frame is now ordered in a descending order. So as you can tell, California, Texas, Florida, New York, and Illinois are the top 5 states. And if you want to see the top result from any data frame, you can use the fhat function to display the first n number of rows. Yeah, so you can select the top 5 rows and it's gonna return the rows that I just mentioned. It's gonna return the states that I just mentioned. Yeah, and these are the top 5 states. And we are going to use the location function because we want to filter the data set based on the criteria. So now we are gonna select the rows if the state column is one of the 5 largest states. So as I said earlier, we are gonna use locate function and we are gonna put in each criteria inside parentheses. And because we are gonna select if the state is California or state is Texas or state is Florida or state is New York or state is Illinois, we are gonna use the vertical line here. So this is the code and it's pretty lengthy, right? So we are gonna run a shortcut here. So this is pretty straightforward. We do the same thing. We are gonna put in the condition within the bracket, but this time we are gonna use isIn function. So this function is very similar to A in ABC list in Python. So if state is in California, Texas, Florida, New York, and Illinois, we are gonna select the data sets. And now I save the data frame as 5 states. And now we are gonna get the income by state level. So we are gonna group by state and we are interested in income column and we are gonna get the mean value. And we are gonna sort in a descending order. So as you can tell, California has highest average income level and Florida has the lowest average income level. And now you are gonna try calculating the total number of employees by state. So if time allows, we can work on this problem together, but if we are running out of time, then you can solve these problems after the class. So now moving on to this problem, we are gonna look into means of transportation to work by state. So as always, we are gonna group by the state and we are gonna select the columns of our interest. And as always, we are gonna put in the aggregate function at the end. So this is the number of residents or employees who use this kind of transportation. As we expected, in all of the 5 states, most population drive to work, and a good amount of people carpool to work, and some amount of people work from home. And moving on to 11, now try this. We are gonna select the California state from 5 states data frame and save it as California underscore transit. And once you confirm your answer, once you're confident with your answer, you can uncomment this line of code and you can save your answer. And in step 2, we are gonna calculate the sum of all transit nodes by county in California. So you can do group by county, and you can put in all of the transit nodes and you can do sum at the end. So this is the last. Now try this exercise problem. And if time allows, I'm going to give you 3 minutes to work on these problems. And anytime you see a data set, you can immediately think to use Pandas and you will be able to answer any questions. And in the later weeks, specifically week 7, we are going to deep dive into the further uses of Pandas to analyze more complicated data. So once you have finished working on all of the now try this sections, you can download your file and you can upload the file in the on the canvas. And these are the resources, and this is the appendix. If you are interested in working with more data sets, here is how you can download the data set from a website called Kaggle. So thank you so much for attending the session today, and please let us know if you have any questions, and feel free to ask any questions on Piazza.